Imagine if one mathematical algorithm could change the entire future of artificial intelligence. Without it, ChatGPT wouldn't exist. Self-driving cars wouldn't exist. Modern image recognition wouldn't exist. Today, we're uncovering the fascinating story of backpropagation, the algorithm that transformed neural networks from an abandoned idea into one of the greatest technological breakthroughs in history. But this story isn't just about mathematics. It's about rejection, persistence, scientific rivalry, and a myth that lasted for decades. Part 1. The myth that almost killed neural networks. In the late 1960s, artificial intelligence was split into two competing camps. One believed intelligence could be created by writing logical rules. The other believed intelligence would emerge from artificial neurons learning from experience. The second approach was called neural networks. Then, in 1969, two famous AI researchers, Marvin Minsky and Seymour Papert, published a book called Perceptrons. They mathematically proved that a single-layer perceptron could not solve a simple logical problem called XOR. Many researchers interpreted this as evidence that neural networks were fundamentally limited. Funding disappeared. Interest collapsed. This period later became known as the first AI winter. But there was one major problem. Minsky and Papert had only proven the limitation of single-layer networks. They never proved that multi-layer neural networks couldn't solve the problem. Yet many people assumed they couldn't. Part 2. Geoffrey Hinton refuses to give up. While most researchers abandoned neural networks, a young student in Britain refused. His name was Geoffrey Hinton. Even as a teenager, Hinton was fascinated by one question: how does the brain learn? He studied physics, then physiology, then philosophy, then psychology. None of them gave him satisfying answers. Eventually, he decided that if he wanted to understand intelligence, he would have to build one. During his PhD at the University of Edinburgh, Hinton continued studying neural networks despite almost everyone around him believing they were a dead end. His supervisor repeatedly encouraged him to switch to symbolic AI. Hinton refused. Every 6 months, he promised he was close. Every 6 months, he continued working. That persistence would eventually change history. Part 3. Frank Rosenblatt was already thinking ahead. Interestingly, the idea that eventually became backpropagation wasn't entirely new. Years before, psychologist Frank Rosenblatt, the inventor of the perceptron, had already realized something important. A neural network shouldn't only adjust the final layer. Hidden layers should learn too. He even described a process he called backpropagating error correction. The basic idea was simple. First, the network makes a prediction. Then, compare that prediction with the correct answer. Finally, send the error backward through the network and slightly adjust the connections. The concept was brilliant. Unfortunately, Rosenblatt didn't yet have the mathematics to make it work efficiently. The idea was ahead of its time. Part 4. The hidden problem, symmetry. Rosenblatt also discovered another obstacle. Suppose every neuron starts with exactly the same weights. Since every neuron behaves identically, they all learn exactly the same thing. Instead of many intelligent neurons discovering different features, the entire hidden layer behaves like a single neuron copied many times. This is called the symmetry problem. Hinton originally believed randomness had to be introduced into each neuron's output. Years later, psychologist David Rumelhart proposed a much simpler idea. Instead of making neurons random, simply initialize every weight with a different random value. Problem solved. Today, this simple trick is used in virtually every neural network. Part 5. The birth of backpropagation. In the early 1980s, Geoffrey Hinton, David Rumelhart, and Ronald Williams combined several earlier mathematical ideas into what we now call the backpropagation algorithm. Here's how it works. Step 1. Feed an input into the network. Step 2. The network produces an output. Step 3. Measure how wrong that answer is. This difference is called the loss. Step 4. Use calculus, specifically the chain rule, to calculate exactly how much each connection contributed to the error. Step 5. Adjust every weight slightly in the direction that reduces the error. Repeat this process thousands, millions, even billions of times. Eventually, the network learns. This simple loop became the foundation of modern deep learning. Part 6. Why backpropagation was revolutionary. Older machine learning algorithms required humans to decide which features were important. For example, if you wanted a computer to recognize cats, humans first had to tell the computer what ears, whiskers, or tails looked like. Backpropagation changed everything. Instead of humans designing features, the neural network discovered useful features by itself. Early layers might learn edges. Middle layers might learn shapes. Higher layers learn objects like eyes, noses, wheels, or faces. This ability to automatically learn internal representations is what makes deep learning so powerful. Part 7. The Legacy. Although many researchers contributed to the mathematics behind backpropagation, including Paul Werbos, Henry Kelly, Arthur Bryson, Seppo Lineinma, and Shunichi Amari, it was the work of Rumelhart, Hinton, and Williams that finally demonstrated its enormous practical power. Their paper, published in Nature in 1986, reignited interest in neural networks. Years later, Geoffrey Hinton, Yann LeCun, and Yoshua Bengio would become known as the godfathers of deep learning. The technology that powers modern AI, including ChatGPT, stands on the foundation they helped build. Ending. The story of backpropagation teaches us something bigger than artificial intelligence. Sometimes an idea isn't wrong. It's simply waiting for the right mathematics, the right technology, and the right people to believe in it. For nearly 20 years, neural networks were dismissed. Today, they power some of the most advanced machines humanity has ever built. And it all began with one remarkable idea. Learn from your mistakes. Call to action. If you enjoyed this deep dive into the history of AI, subscribe for more videos exploring the people, algorithms, and discoveries that shaped modern artificial intelligence. Because understanding the past is the best way to understand the future.